In section 4.2, we're going to be graphing polynomial functions. Now, if you watched my video from section 4.1, we talked a lot about that leading term in the polynomial function. Well, now we're going to use the leading term to figure out a lot of what the graph is going to somewhat look like. But then again, we're going to continue on using the different parts in the function to make the full graph by hand. So we're kind of like sketching the graph now by the information that we have learned in section 4.1 and now in 4.2. So here are some of the steps in order to graph a polynomial function. We're going to again use a lot. The leading term test, or the leading term in the function, is going to give us a lot of what the behavior is going to look like from the start to finish. And then we need to find the zeros, the x-intercepts, the y-intercepts, some additional order pairs in order to kind of fill in what the graph should actually look like. And then we can do a check also. So here's our function that we want to graph. Once again, we have to look to see if we can do factor by grouping. Again, if you have 1, 2, 3, 4 terms in a polynomial function, we can do our factor by grouping. So let's go ahead and do that now. So here's the function. Let's group the first two together and find the GCF. And then group the last two together to find the GCF. So if I'm looking at this term here and this one here, what can I pull out? Always pull out the smallest exponent if you can. And then because the coefficients in front, you can't find a GCF of 2 and 1, you just leave that alone. So for this one here, we're going to pull out an x to the second. And then what does that leave you with in the inside? So that's going to leave you with 2x plus 1. So if I actually did my distribute this time, this gives us the x to the third, and then this one here gives us the x. And actually is going to be this should be a plus sign. So let me change that real quick. So this should be a plus sign up here. All right, so now let's look at the second part. And here I see I have a -8 and a -4, so I can pull out a -4. Again, I want my leading coefficient in front here for this part to match this one. So because it's a minus, I want to pull that minus out also. So I'm going to pull out a -4. If I pull out a -4 here, that leaves me with just 2x. See how it matches this one over here? And then if I pull out a -4 and then the -4, it leaves me with a +1. So both of these sides match. So we write it one time. And then whatever is left over in front, we make that into a factor. So x squared -4. So once again, we always check to see if you have a difference of squares. A difference meaning subtraction. Can I take the square root of this one? Yes. Can I take the square root of this one? Yes. There's a subtraction. This is what is called a difference of squares. If I do that, I already know it will come down to x plus 2, then x minus 2. And then we can drop this one down because we can't do anything with it. My pen ain't acting right. There it is. Okay, so here, from here, we can, once we find our factors, we can figure out our zeros, right? So this one for the first part, -2. If I set it equal to 0, for the first part here, it'll be +2. And then over here is going to be a -1/2. So these are considered to be my zeros for this equation. And what does zeros also associate with? It'll be your x-intercepts also. Well, with x-intercepts, remember, write it as an order pair and place the 0 in the proper spot. So let's go back to finding the leading term. Looking at leading term here, because this is an odd, we know it's going to go in one direction and end up in a different opposite direction. And because it's a positive, I'm going to start negative and going to end in the positive direction. So this is what it's going to look like. Now we're going to be working with now in this section what this middle part is going to look like. But we know where the starting and stopping points is going to end by just looking at just the leading coefficient. This is all in section 4.1 of that leading term. So this is another example of what I went over before in section 4.1, just some examples of what the middle part looks like. So the little squiggly lines that you see in the graph right here, this is the little action that it's talking about right in here. So this is what we're going to be figuring out by hand in this section, this little squiggly stuff. So we find the zeros here. This is where I factored and got here in my on the whiteboard. So -1/2, -2, and 2. Make it into x-intercepts by putting the 0 in the y-coordinate spot. And these are going to be, if you can't, again, factor, use the calculator to figure out your zeros also. Each of these has a multiplicity of 1 because it only occurs one time. Here's -1/2, -2, +2, all are 1, so that they all have multiplicities of 1 for this one. So what we're going to do now is step 3 is figure out the intervals using test points. So we know that our zeros was -2, -1/2, and then +2. So we're going to start from negative infinity, and we're going to end up to our first zero, which is -2. So you want to kind of go in from smallest to the greatest. So this is the smallest one, this is the next one, and this is the next one. So this -2 came from here. We go from -infinity to 2 and stop. Then what the test value means, I want you to pick any number in between -infinity and 2. Obviously pick a small number, an easy number to place in to do the test. So I picked for the smallest number that I can think of in between here, which is going to be -3. If I plug -3 in for this x here, and then this x here, and I calculate, this function here is going to equal to -25. Which means the sign is negative, and they're one of the ordered pairs or the maximum minimum is going to be below the x-axis, and I'll explain that in the next slide. So then we go from -2 to the next zero, which is -1/2. Pick a number in between here, 1. If I plug that -1 into each one of these, my answer is going to be 3. It's positive. So the location of the point of the graph should be above now the x-axis. So anytime you get a negative, once you do your test value, we know it's going to be somewhere below the x-axis. If you get a positive, it will be somewhere above the x-axis in this interval. So from -1/2 to +2, we plug in, we pick a point, 1, plug it in, get -9. Because it's negative, the graph is always going to be from -1/2 to 2 below the x-axis. And for the last one, we plug in a positive, we get above. So here's my negative, my positive from this end of -infinity all the way to 2. This is going to see some negative action. From in between -2 and 1, there's a positive action after I do my test. In between -1/2 and 2, we have some negative action, and then 2 to infinity, we get some positive action. So let's kind of go back and show you an example of what I mean by below and above the axis. So maybe this one right here. So this one here, we see that from this point here to this point here is below the x-axis. And then if I did, this one doesn't kind of go above it, but here's one again that has one from this point here to whatever this point is, looks like 0, is above the x-axis. And then the action in between 0 and then maybe 1.5, it's below the x-axis. So this is where what I meant, where if you put in this interval here, you pick any point, the action should always be below that x-axis. So what have we found what have we found so far? We know that we found our zeros. We found out where it's actually going to cross the x-axis at -2, -1/2, and then +2. We know what the in between, what the graph should be. It should be located below the axis for this one, above or below and above for this one, because we did our test points. The calculator can also do that if you plug this equation in, and then go to ask, and I can kind of show you now. It easily can spit out the negative 25, 3, and negative 9. Instead of us calculating each one of these, it'll be a little bit quicker. Once you clear everything out and then you put in the equation, this is the same equation that we was working with before in my slides. If you hit second and then tape and window, because we want to go to this little where it says in blue, table set. Go down to the independent, that's our x's, and we're going to switch it to ask. So slide it over, hit enter. And then now let's go to our table. So we hit second graph. And I'm going to give that test point. Remember, our test point was going to be negative 3. And if you plug negative 3 into the equation, if you do it by hand, that's fine. But if you want to do it in the calculator, see how we got that negative 25. So we know it's going to be below the x-axis. The next one is negative 1. We get 3. The next one is going to be 1. Here below the x-axis, negative 9. And then the next one will be 3, and that's going to be above the x-axis. So now we're going to determine the y-intercept. Again, it's going to be the last number in the equation, because once we place that 0 in for x-intercept, we plug 0 in, all this goes away. So all these terms go away, leaving with just negative 4. So negative 4 would be our y-intercept. Remember, put it in the order pair. So it's going to be parentheses 0, comma, negative 4 for the y-intercept. Don't just put in negative 4 for y-intercept. You got to put it as an order pair. Okay, so here are my zeros, negative 2, negative 1/2, and 2. So those are my x zeros and my x-intercepts. You see that what we discussed before, from negative infinity to 2, here's my negative. This is above the x-axis. Here's below the x-axis, and this is above the x-axis. So that kind of gives us, it should be above or below the x-axis when we're graphing. So now we just need to go to, you can actually just hit second graph, but make sure you switch it, go back to the second window and switch it back to auto. And then hit second graph, and then you can just grab some test points. Don't grab the bigger ones. Just grab some points that you hear, because we want to make a graph and fill it in, so we can kind of get the actual shape of to sketch the actual shape. So here we just randomly pick negative 2.5, got 9. Plot this point, plot our intercepts, plot our y-intercepts, and once you have enough dots or order pairs, you can actually make what the graph actually looks like. So a lot of steps, a lot of work, but we took this polynomial function. We got all the information by looking at the leading coefficient. We got our zeros for x-intercepts. We got our y-intercept. Plot those. We figured out if it's supposed to be from below the x-axis or above the x-axis. We grab some additional points for hitting second graph. Plot those extra points. Connect all the dots, and that's how we get to our graph. So now we're going to talk about graphing, continue talking about graphing polynomial functions. But this here, we're going to talk about, again, the zeros is kind of more like a recap and all the turning points. So looking at this equation here, we want to find the maximum number of zeros. Again, what do we look for if we need to find out how many zeros or x-intercept is going to be? You look at the degree of the polynomial. So here, the maximum is going to be 5. We have 5 possible zeros for this problem. Because real zeros and x-intercept, they mean the exact same thing, we're going to have that. That's where it's going to cross the x-axis 5 times also. So again, these are kind of similar. So how many turning points do we have? So anytime we need to find the turning points, we take whatever the n is for the leading degree and subtract it by 1. So we have 4 turning points when the graph turns directions. So there'll be 4 times where it does that. So again, If you see the degree is 5, that's going to be our zeros and x-intercepts. Trying to find the turning point is always going to be n minus 1. So just to kind of give you understanding of what some of this stuff means in MyMathPlus here, given an equation here, we're going to put this in our calculator. And we're going to, the MyMathPlus wants us to choose which one of these pictures looks exactly like this function. The way you have to do this is you have to pay attention to the scale that they give you in MyMathLabs Plus. -5 to 5, -30 to 70. So let's look at that in the calculator. So anytime you need to change that, you go to window. Let me go back to the standard way it should look. If you look at window, the first part of the one will be the x min. So we put that as -5. Go down to the x max. That's going to be 5. The scale, when it says x scale, that means how many little tick marks it goes up by how much you counting going up to it. So we're actually going up by ones, which is fine for this one. This one here should be -30, and the last one should be 70. And again, we get it from -30, 70. So x min, x max, y min, y max. Here's the scale. It'll be 1 here. We're going to change this scale for the y because these numbers are a little bit bigger. We're going to go up by 10s. And then that's when you hit graph, and then it shows you the picture. I didn't type the equation in, but once you type this equation in, it shows you the picture of what it should look like for this one. Now, when you look at the picture, when you hit on the graph button, when you have your window set and you hit graph button, it's going to look like this one or A. It's not going to look like this one. We actually don't need the calculator even to identify it looks like this one because we know this is a odd because it goes from one direction to the opposite direction, and we already know this is a even, so that means it's going to end up going in the same direction in both ways, and it's positive. So that's why we can know it's going to be A or B. However, what we need to choose from is going to be the last term here, which is going to be -21. What does that last term mean? That's the y-intercept, where the graph hits the y-axis. And because these are going up by 10, remember, as far as tick marks, so this is 10, 20, 30, 40, 50, going forward. Going down, it's going to be -10 here. This is -20. Well, if this is going to be -21, then I need my graph to at least go down to -20 somewhere in this area, which it does not. So this is why A is the more logical answer, because this is going to be -10, -20, which is close enough to -21. So this actually concludes section 4.2. If you have any questions or concerns, please let me know.